really hear me. So I started switching over to a different mic, and then the other mic didn't pick up at all. So I was like, well, crap, I guess I'm re-recording it. All right, so today we are going over the graph of a function and what you can kind of tell from it. So I know it's going to be a little difficult to kind of sketch this graph in your notes, but I want you to kind of try. It doesn't have to be perfect. Oh, you butthole. Stay. So try and sketch it in. At least like do the sketch and then plot the same points. It doesn't have to be perfect. All right. So, the first three are pretty straightforward. It says f of negative 5. So what do I need to do? Okay. Yep. Go to negative 5 on my x, go up, find the y. So f of negative 5 equals 8. No work involved. All right. Shout it out. What is f of 0? Negative 4. And what is f of 3? 4. All right. For the next couple, I'm going to give you both interval and set builder notation so you can kind of start seeing the two differences. All right. Domain is always what x values this graph works for. So what is the furthest left it goes on that graph? Negative 7. Now, because that dot's closed, I'm going to use a square bracket. I don't know why I started like curving on the tail of my 7, so sorry. All right, what's the furthest right it goes? 3. Okay, so that is interval notation. All right, set builder notation would be like this. Squiggly, x such that x is between negative 7 and 3. Squiggy. Do you want to try range with your neighbors? Okay, so if domain is x, what does range need to be? Y. So, chat with your neighbors. Try filling out range, and I want you to do it in both interval and set builder. What do we think? For range, how low does it go? Negative 8. How high does it go? Positive 8. All right, and then set builder. y such that y is between -8 and +8. How many of you are struggling with the squigglies? Not a fan? I was going to say, I had a class yesterday that threw an unholy hissy fit about trying to do the squigglies. Alright. Copy. So we got some more that we've got to do. Intercepts is the first part. Do you think you can label all your intercepts? Alright, chat with somebody around you, label them all, see if you got the same thing they did. How many did you guys end up with? How many intercepts? Should have 4. There are 3 x-intercepts, 1 y-intercept. So when I list it, I go y-intercept at 0, -4, and then I've got x-intercepts at -6, 0, -2, 0, and +2, 0. Ready to scroll? Or I'm at least going to move it so we can see intercepts at the top of the page. Make our lives a little easier. Oh, you stupid thing. So take a second. Let's copy some of those down. Alright, ready? So how many times does the line y = 2 intersect the graph? And where do we think that would be? Is it a vertical line or a horizontal line? Yeah, it's a horizontal line. So, be about there-ish. How many times does it intersect that graph? 3. It doesn't necessarily have to be exact. We're just trying to get an estimate as to where we need to be. All right, next part says, for what values does f of x equal -8? -7 and +1. So x equals -7 and x equals 1. All right. Now the last part is saying, for what values of x is f of x greater than 0? So if we need to translate that into common speak, how would we do that? Explain it like I'm 5. Yeah, for what values is my graph above my x-axis? All right, so I've got a section over here on the left, and that goes between -6 and -2. And then, well, we should make that square brackets because it does include those. And I've got 2 to 3. Yes? We okay with that? Yes? No? Okay. All right. Here is our next part.
The ones that are on the line be,
like the parentheses. Ooh, good point. So it says greater than, not greater than, or equal. So, yeah, we fix that. So did you guys hear the correction as to why these should be parentheses? Yes, no. Who likes puppies? Raise your hand. We're getting the words that are coming. Did you guys hear the explanation as to why these should be parentheses? No? Some yes, some no. So, these should be parentheses because it says greater than 0, not at 0. So, the parts that we're looking at, these dots, are where it equals 0. 0 is not greater than 0. 0 is equal to 0. Does that make sense? Shane? Yes. Now we're good. All right. Scrolly scroll. All right, ready to talk this one? Okay. So, it says state the domain. Is there any potential issue that I could have that would take something out of the domain? Yes. What? A -2. That would make my denominator equal 0. So, interval notation, -infinity to -2, -2 to positive infinity, or set builder x such that x does not equal -2. All right, what do we think for that second one? If x equals 2, what is f of x? What do I do? Yeah, plug in 2 for x. Don't overcomplicate it. 2 plus 1 over 2 plus 2. So this equals 3 over 4. Now, how would I check that next one? Is the point 1 and 1/2 on the graph? Shane? Yeah, and see if it equals 1/2. If it is, cool. If it's not, also cool. Now I have an answer. 1 plus 1 over 1 plus 2. 2/3. Does that equal 1/2? Nope. All right, so here's our next 3, and I just copied and moved the equation down so we still have it. All right, for this first one, do we have any ideas how we want to solve it? Yep. Equal 0? That one. No, you're good. But you're on the right track, so instead of it equaling 0 for x-intercepts, yeah, I'm going to set it equal to 2. So 2 equals x plus 1 over x plus 2. Now, when you're ready to solve this, we're going to multiply both sides by x plus 2. do a little bit of algebra and solve for x. And then for that second one, we're going to do the same thing, except we're going to set it equal to 0. Now, if I set this equal to 0, what happens to this x plus 2 in the denominator? Yeah, it goes away. So I get to be a little lazy and say, okay, 0 equals x plus 1, so x has to equal negative 1. And then how would I find y-intercepts? Set x equal to 0? Yeah?
Yeah.
0 plus 1, 0 plus 2. And then if you're doing a coordinate, 0, 1/2. Ta-da!